All right. Greetings, YouTube. Beautiful mind here. So this question comes in from calculus. I'm not going to lie. I had to do a little bit of research because I tried it a couple of times and it didn't work. I'm going to do the best I can to be as concise as possible and as clear as possible. Some of the stuff gets a little bit fun. I just want to share this bit of information I just got. So a friend of mine just sent me a video. It's concerning the coronavirus. And long story short, the claim is that the people of Wuhan, China, to treat the corona, what they do is like they drink hot water like 4 times a day. They drink hot milk and tea and like 6 times a day. They drink and they steam like as much as possible throughout the day. All right. So they're constantly inhaling these hot liquids as hot as they can tolerate as often as possible with about the rhythm that I mentioned. And they do this for about 4 days, and on the fifth day they take another test, and that's the claim that the video said is how they were handling corona there. Where and we think about Chinese culture or whatever, they definitely drink a lot of tea, and here in America we definitely do not as a collective, right? So that might be something. There might be something there. Okay, it made total sense to me. I could see it. So you make the environment for the airborne illness. You make it difficult for it to survive. So I'm not. I just thought it was an interesting video. I think there's some merit there. I'm no health expert, um, but again, it just made sense to me. So that's just a side note. Okay. So now here, let me make sure. I think we're recording. Yeah. So here, we're actually using L'Hopital's rule to evaluate each of the limits below, right? Okay, so let me start like this. I usually like to write on graph paper. And let's start with number 6, right? So we have the limit as x goes to 0. We have this 1 over x minus e to the x minus 1 under 1, right? So L'Hopital's rule basically says if you have the limit as x approaches a number of one function over another, and if you just try to evaluate the limit directly, you get I think it's like an indeterminate form, something like 0 over 0 or infinity over infinity or 0 to the infinity or infinity to the 0, something like that. Then L'Hopital's rule basically says you could take the derivative of the top, take the derivative of the bottom, and then try the limit again, and then you might be able to evaluate the limit. All right, that's the gist of L'Hopital's. Now these 3 examples, let's just see how they evolve. So, so what I'm going to do, I'm going to combine these 2 fractions into one fraction, right? So first, I'm just going to focus. I'm going to kind of ignore the limit for right now, and I'll come back to it. I want to focus on this 1 over x minus e to the x minus 1. And I want to combine these into one fraction. So what I'm going to do is, like when you add fractions, you get a common denominator. So my common denominator is going to be x times e to the x. So the first term, I'm going to multiply by 1 in the form of e to the x minus 1 under e to the x minus 1, right? So I'm multiplying by 1 in that form. The second one, I'm going to multiply by 1 in the form of x over x, right? So multiplying by 1 doesn't change the answer. It just changes the form into something that we can do, all right? So then if we go with this, the top is going to become, we're going to have e to the x minus 1. Then on the right-hand side, we're going to have minus x. And then on bottom, we're going to have x times e to the x minus 1, okay? So all we did was rewrite the original expression at hand in question. And so now let's see, now let's apply L'Hopital's rule, right? So let's just focus. Let's focus on the top first. Let's take the derivative of the top, which is going to be, I'm going to write it like this. For the numerator, that's going to be d by dx of this. We have e to the x minus 1 minus x, right? Let's take the derivative there. But then that's going to be equal to d by dx of e to the x minus d by dx of 1 minus d by dx of x, right? So e to the x is an interesting expression because it's its own derivative. So d by dx of e to the x is itself. D by dx of a constant, this goes to 0. D by dx of x, this goes to 1, right? So then it looks like we have this minus 1. Now that's the derivative of the top. Let's go ahead and do the derivative of the denominator of the bottom, basically, all right? So that's going to be the derivative, or d by dx, of this x times e to the x minus 1, right? Okay. So I feel like what I'm going to do, I'm going to distribute this x. I feel like this might be a little bit easier to see, all right? So if we distribute the x, then we're going to have d by dx. We're going to have x e to the x minus x, okay? So then if we're going to evaluate that derivative, that's going to be d by dx of x e to the x minus d by dx of x, right? So for that first term, we have to apply the product rule. First times the derivative of the second plus the second times the derivative of the first. So that's going to be x times d by dx of e to the x plus the second, which is this guy, times the derivative of the first, d by dx of x. Hopefully you're able to keep up with this because I know it's a little bit intense, okay? And then I'm just going to I'm not going to evaluate this on this line. I'm going to just bring it down, right? So now let's evaluate all these all these derivatives. Again, derivative of e is itself, right? So that's just going to be x e to the x. The derivative of x, this term by itself goes to 1. So then what's left over is just going to be this e to the x. And again, derivative of x, that goes to 1. So then that's going to be minus 1, right? So this is the derivative of the bottom. So now let's go back. So now, let me see. So the first one, we got this is one result, and we got this is another, right? So now let's evaluate the limit. So now let's do the limit as x goes to 0 of, the bottom is x e to the x plus e to the x minus 1, and the top is e to the x minus 1, right? So now in the original, if we just try to plug in the 0, we're going to get a lot of indeterminate forms. Like we're going to get, we can't divide by 0, right? So we would divide by 0 there, we would divide by 0 here. We can't do that, right? So then we got into a fraction, we applied L'Hopital's rule, and we got to this part. So now let's see if we can just evaluate the limit. If we evaluate the limit, essentially just plug in 0, then on bottom we're going to have, so let's see, this first term is going to be 0 times 1. So this goes to 0. This e to the 0, this is going to go to 1, right? Let me think about it. Do we need to take a derivative again? Okay, so we ran into a snag, right? Because here, the first term is gone, but if we try to do e to the 0, we're going to have 1 minus 1. We're going to be dividing by 0. So let's apply L'Hopital's rule again, right? Because we can't do it at this stage. So let me back up. So let's apply L'Hopital's rule one more time. Undo. Okay. So let's just take the derivative one more time. So then this is going to be sorry. So I want to do d by dx of the bottom, this thing, and I want to do d by dx of the top. Okay, let's just do this and see what happens. Now, I'm going to do this in a little bit more shorthand. The derivative of e to the x is itself, so this is going to be the limit as x goes to 0. The derivative of e to the x is itself, so that one persists. The derivative of 1 is 0, so that's gone. this first one, we got to use the product rule. So here we have to use the product rule. So let's just do it. It's going to be the first times the derivative of the second, which is this, plus the second times the derivative of the first, which is that. Again, derivative of e dx is itself. And the derivative of 1 is 0, so that term is gone. All right. So now I think we're ready to evaluate the limit. So now if we try to apply the limit on bottom, again, this first term, 0 times 1 is 0, so that's going to go to 0. E to the 0, so then what we're going to have, on bottom, we're going to have e to the 0 plus e to the 0 under e to the 0. So then this becomes basically 1/2, right? So I'm not going to lie. Like the first time I did it, I did L'Hopital's rule initially, and it just didn't pan out, right? So then something said, well, just apply the rule again. No, actually, I got an answer, or it wasn't panning out, and then so what I did is the following. Let me show some other ideas here. What time is it? I think my alarm is going to go off soon. I got like 30 minutes. Okay. So let me